Hello students, welcome on YouTube channel of Lalbagh Girls Inter College. This is Kirti ma'am and this lecture for class 10 maths. So students, in my previous lecture I had explained basic proportionality theorem, that is Thales theorem. So I'll show you what is a Thales theorem. This is the Thales theorem, which are stated as if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, then the other two sides are divided in the same ratio. That is, if any two lines which are parallel, that is DE is parallel to BC, and then AD upon DB is equals to AE upon EC. This is the Thales theorem. Now in this session I am going to prove converse of Thales theorem, which are stated as the converse of Thales theorem is if a line divide any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So students, I'll show you with the help of the diagram. So here ABC is a triangle and a line L intersecting AB, this side AB, at point D and AC at point E, such that AD upon DB is equals to AE upon EC. AD upon DB is equals to AE upon EC by Thales theorem. Then we have to prove that DE is parallel to BC. So now we have to prove that DE is parallel to BC. So first of all, we have to consider if DE is not parallel to BC. We have to assume DE is not parallel to BC. Then there must be exist another line through DD which is parallel to BC and which are DF. This is the another line which are parallel to BC. Then such that another line DF is parallel to BC. So that is DF is parallel to BC. Then by Thales theorem, if two line is parallel to each other, then the ratio between their sides are equal. That is AD upon DB is equals to AE upon FC. So I can write AD upon DB is equals to AF upon FC. This is equation number 1. but we have to given that AD upon DB is equals to AE upon EC. AD upon DB is equals to AE upon EC. This is given. So now I'll take the equation number 2. So by equation number 1 and equation number 2, you can see that the term AD upon DB and here AD upon DB are same. So that AF upon FC is equals to AE upon FC. So from 1 and 2, we have AF upon FC is equals to AE upon EC. Now after that, adding 1 on both sides, then we have AF upon FC plus 1, and similarly AF upon AE upon EC plus 1. So we have AF plus FC upon FC. I'll take an LCM of FC. Then similarly I'll take EC as a LCM. Then AE plus EC upon EC. So AF plus FC, you can see in the diagram, AF and FC, it's exactly a AC line. See, AF and FC is a sum of these two sides is AC. So I can write here AC upon FC. Similarly, AE plus EC in the diagram, AE plus EC is also the side AC. So it is also AC upon EC. Now I am going to eliminate AC on both sides. Then we have 1 upon FC is equals to 1 upon EC. So such that we have FC is equals to EC. So which is possible only when F and E is coincides. That is, F and C are not a different point on the side AC, which actually lie on the same point. Then which is possible only when E and F coincides. When E and F are coincide, then I considered that DF is parallel to BC. So we say that DE is parallel to BC. Because E and F both are a single point. So we have to conclude that DE is parallel to BC. So this is the conclusion of the theorem, which is converse of Thales theorem. Thank you.